Alright, hi everyone, welcome to another stream. So the thing that I was working on sent between last stream and now is a basic test system. So basically, let's see. If this is a debug build, then it's going to run through all of the tests. Just runs here. Tests are just a struct, which can have input code, and then it can check for different types of outputs. Currently, it's just to check if the AST matches, and then this is just what each test looks like. I only have, I think, 3 or 4 made now. Then it loops through all of those, and essentially just compiles the code and makes sure that the test works. So if I compile, and by default it compiles to debug mode, it runs all the tests and it says all tests pass. So I'm probably going to add maybe like a few more, just so that it's sort of comprehensive, and then I'll start working on some other stuff. Oh, and that's just what it looks like when a test fails. It just prints out what it expected the test to be, and then what the actual thing was. Hi, welcome to stream. Okay, so now that's a macro definition test. Oh, and for the tests, I have, it's just super basic things. Like the first one is just creating a main function. Right now I'm working on test definitions, and I haven't fully decided what I'm going to start working on next. It's either between creating some kind of output, which would probably temporarily just be C code, although eventually it will be LLVM just because of its capabilities to, optimize. But yeah, it'll probably just be C code, transpiling the C code, and then compiling the C code on its own. Or I could try sort of working on like the dynamic linker, because I also want it to be able to execute code during compilation, so it shouldn't have to already be fully compiled before the code can run. So it's going to have to dynamically link from the compiler. And I've never done that before, so it'll definitely be a learning experience. So for the test, yeah, I have just a main definition, and then this is just a main definition with 2 plus 2, and just make sure, yes, that equals 4 down here. It doesn't actually execute this code, but it's basically just checking to see if the AST is created exactly like this, and if it simplifies the expression 2 plus 2, because that should just be simplified equal to the literal 4. And then this is just a for loop with a range. This is a for loop with a range and a iterator. So yes, it's pretty simple. I also want to test file includes. So I'm going to have to create some kind of never changing include, I guess. Because things like the print module is definitely going to change over time. Okay, so then that's the basic test module. Yes, this is the second channel. I used to only do streams on it, but I'm also going to probably, well, I posted one video, which is sort of like a lower effort one. Also not really on topic, but I guess I don't really have a topic on the main channel either. Anyway, I'm going to start putting more, like, video content rather than just streams. Basic dot test. Segfault. What? I was not expecting a segfault. I guess I have to see what that is. Load module. Huh. Hi, welcome to the stream. Okay, so I think it's because I'm accessing a child node, which, you know, I definitely should have added a check here. What, 91? I know, I want to, yeah, this. I think that's actually enough. That's why I was taking the size of a node. It's not correct. All right, there we go. So I think I can copy most of this AST up here. So it should look like this. Nothing node, identifier node, scope, scope. Okay. Oh, sorry. Yeah, I wasn't really talking. Um, well, if you have any questions or, I don't know, anything like that, I'm happy to answer them. But yeah, implementing tests. Well, the AST is building an AST in C++. It looks pretty similar to the output that I have, but there is still like a bit of thinking and work that I have to put into this. I would create like a parser so I could just copy and paste this in, but then that's like an extra point of failure. I mean, maybe if I made it like very good, but I don't think I could make one that's very good. I'd rather have it so that everything that the compiler needs to be that is like mission critical is like written in C++, the same language as the compiler. Yeah, I'm technically a computer science major, but I might change that or something at some point. I don't know. Okay, so I have the full import done, I think. Then I have to define the function. I think it should be like that, but I don't remember if I'd left it with a type. Identifier. Oh, and it has a return. That's a good question. Projects to increase your chances getting a job. Unfortunately, I technically don't have a job, so I wouldn't know. Oh, so it's expression term. Integer. Okay, this test is complete. Awesome. Although, now that I think about it, I will probably want more than one test module. So yeah, let's have this be under a test directory and then call this like test 1. Oh, you know, something else that I could do today is try to implement pseudocode of a game. I mean, I already have pseudocode, like, this is all technically still pseudocode. But like a full game, because that way I can actually see sort of, like, how it would work in, like, real industry. Although the game will just be Pong, so I guess that's not really a high-grossing game. So let's make a new directory at modules slash. Actually, it shouldn't be in basic. It should be in. Yeah, it should be in. Wait, hold on. Yeah, let's make a test. Just its own entire directory. And then I can do. I'll be completely honest with you. I think AI is a bubble. Well, I mean, it is technically currently, because most of the funding is, well, actually, almost all funding for, like large companies, even like OpenAI and stuff, is basically VC. So investors, not actual products, and so I don't think you should really be trying to make a product in that. I mean, basically what I'm saying is there's basically an AI startup every like half mile. So you probably should not try to enter a saturated market unless you think you have something that is like really, really good. And I don't think anyone has that yet. Print test. Oh, and I actually need to change where this is imported from. So it's from test, and it's test 1 module. Okay, so I also need to rename that. Alright, awesome. Oh, and I also created a printout so that it does say like what modules are actually imported. And I also made it so that you can increase verbosity by just adding these. So if I add, well, I guess one V didn't really do anything in this case, but if I add another V, then that also prints out the AST. And it should also print out the exact directory where the module is imported. So here you can see module print imported from, and then that's the full path to the module. And that's probably pretty useful if you accidentally have a module copied to your current directory, or if you just want to know where your module's directory is. So, you know, that pseudocode project I guess sounded fun. So I think I'll work on that. Exit out of... yeah, that too. Oh, I need to create a new directory. Well, the compiler will compile to machine code eventually. I plan to eventually implement LLVM, which is like a backend for compilers, so that I don't have to do all of that on my own, especially because it has some really good optimizations. But currently it doesn't compile to anything, but I might make it compile to like C temporarily. But it will be to machine code eventually. Alright, let's start this Pong. So I'm going to have some kind of rendering module. And I did sort of decide it's going to have some object-oriented components. So it's probably going to be more like C++ than I probably originally had in mind, because I want it to be easy to make like games and stuff. Still not completely outlined, so hopefully, you know, writing some pseudocode will make that more clear to me, but, you know, let's see how it goes. So I think it's going to be a little overcomplicated maybe for Pong. But I think having a method that I can use to easily create like more complicated games in the future without doing much extra work would be nice. So I'm going to create like a game object type. And I think that sort of makes sense. Math.vectors will include like a vector type. So then that will define something like vector3. Currently it doesn't communicate with the graphics card at all, but it will be able to I mean, it will be able to. I haven't really decided how the libraries will be handled yet. I don't really know how currently that would even be implemented, but I'll figure it out. Yeah, there is definitely a line between this language and like it being a game engine. I'm going to make it so that you can make a game engine in the language, um, and that would just make game development easier in it. But you can also just do it from scratch. Um, Still really haven't figured out variable typing. I might just leave it the same as it is in C++, because I do kind of like that. So that would be vector 3. You should be able to. Well, if you're asking OpenGL, Vulkan, or DirectX for the language, any of them. You can use anything you want. That's the goal. Um, really, anything that's implemented, you should just be able to use. I haven't decided what will be like the first one that I'll start on. Uh, Probably just depends what's easiest. I haven't really thought about how I should have like a derived, something that's derived. Oh, it's very early. It's only 5 p.m. for me. Um, Maybe I could do something like this. That's kind of weird though, isn't it? Well, I guess I'll just leave it like that. Or... No, that's bad. Yeah, I think I'll just leave it like that. Although it really might not fit with the style language that I'm wanting. I don't know. Actually, I might not even need a derived struct for that. I don't have a concrete list of the data types that are going to be implemented, but it will be, all of the primitive ones, and I'm going to probably have string be a lot very well implemented on the compiler side, so I don't have to write all that much for like a library. Um, and then I'm going to have a default list type, kind of like vectors in C++. I also need a input. Oops. Keyboard. I'm still not entirely sure how much I should like delineate these. I mean, I don't want it to get to the point where it's like Java, where you have like 10 different like words here that you have to exactly specify. Oh, also, I don't have single quotes like in C++. When you want to define like a character, you can do like something like this, where you use single quotes to indicate that it's a single character, and you have to use double quotes if it's a string. That's kind of stupid, in my opinion, so I have it so that you can use double quotes, and then that can be a character or it can be a string, depending on the use case. Now, obviously, since types are by default inferred, that might cause some problems, but I'm going to do like a very well implemented checking system, hopefully. So it shouldn't be all too much of a problem, I don't think. So this is going to be passing a character literal. Hmm. Well, it's probably because I'm not much of a comedian. Keep that as move. And then these will be pile types. I'm also going to make it so that by default in the rendering, plus Y is actually up the screen. Because, I mean, that's just how it is in like most game engines and stuff, so I think that would just make sense. Because by default in rendering, plus Y is down. But you shouldn't really be having to do a whole lot of manual rendering stuff. The libraries should be implemented, I think. So I think I'll leave it like that. I think I'm probably writing this too much in the style of C++. Yeah, so this definitely won't be the final version. Cloud code tab complete? I don't really know what I don't know what you're referring to. I don't use AI tools. So I probably also want a sprite type. No, I'm not going to give them a shot. I'd actually rather you don't try to endorse them because they make you a bad programmer. So the sprite struct is going to have some kind of image game object associated with it. All of this stuff is probably going to be moved to different modules so that you don't actually have to implement it every single time, other than this derived struct. I also might want to make it so that you can just include rendering as a whole and not all these individual modules. But that would sort of have to change the module system a bit. Not that it's implemented well as it is anyway. Something I don't really like is the way that class and structs are initialized by default in C++. You basically create something that looks like a function. Like in C++, it would be something like this. And then you have to pass some kind of variable or just leave it as it is. And I don't know if I want to borrow that sort of style. Maybe it could be something with like a keyword. And you should still be able to pass arguments to it. New. Yeah. Well, no. I don't know, I might want to reserve new for like a keyword. I don't know, I'll think about it. And then there's the fact that, you know, friends are used there. I don't know. I mean, you get used to it, you know, over like the years that you actually use the language. But if you just like step back and think about it, it's kind of weird looking. So alright, so each of these panels should have an associated sprite type. Well, okay, so I can't name it sprite. Are you asking if I'm an Arch Linux user? No. Currently I'm using Windows. This is Windows Terminal. And this is Debian inside of Windows Terminal. So I probably want to have some kind of path given, and then that's just the worst thing. Alright, so on creation of the sprite, yeah, so not sure about initialization, but I'll work on that. Guess I'll just have some kind of file here. Oh, and Sprite 2D should obviously have some modifiers. I also don't know why I'm using vector 3. I can probably just use vector 2. Scale. By default, vectors are probably going to be initialized as 0 vectors, so I want this to be a 1 vector. Okay, and then I'm going to... Oh, I should probably have another method for drawing the sprite. Yeah. And then I can do draw image. Passing the image, the position, and the scale. And it will also need rotation. I haven't been working on the robot dog at all. And I don't plan to either. I think at the end of the video I said I'd work on one more like the Boston Dynamics one. But the problem is that those actuators cost quite a bit, so I'd be looking at spending like maybe $3,000 for that project. And that would be a really expensive project compared to what I've worked on so far. Alright, and then inside of paddle, I guess I can just have another draw function, which just runs sprite.draw. I did face reveal because I used to have the camera going when I did voiceovers for the videos, the old videos on the channel, like for game development stuff. But I don't think most of those videos are up anymore, or at least they've been unlisted and put in the playlist for the unlisted videos. So I don't know if anyone even knows. The reason I just don't have those videos with face anymore is just a stylistic choice, because it like puts more focus on the actual like content and the project that's going on. Also, it's a lot less effort. Yeah, some of those are members only. I think some of them are just unlisted though. They are old though, so it's like face reveal from 5 or 6 years ago now. And then casting, that's gonna be difficult. I mean, I guess I can do something like this. I feel like I'm basically making C++ code now, though. position dot, or no, rotation dot z. And I can leave scale the same. Or no, actually, I want the X scale to be smaller. So let's just create an overload for create. Oh, then I'll do vector 2 there. Make it like 0.2 and 1. Okay, and then now down here I can just go through the paddles. The what? Extended mind thesis active externalism. Is that something I can just, I don't know, look up? Run the draw method on just each of those. Alright, now let's create a... Oh, actually we have to limit movement. Let's do like... I don't need float there. Say next position is equal to that. Oh, oops. Plus. If X position is greater, and then I probably want to set like a max in here. Or actually I can do min max. if it's 512 by 512, then I probably want that to be, well, like 0 and 512, but probably a bit different from that. Whatever, we'll be able to test it when I can finally compile this code. Alright, so if next position is greater than position.y, then if next position is less than min-max.y, alright, bye. Thanks for watching. Next position. I think I can copy most of the code from the paddle, the ball. Okay, so I think for casting, I'm just going to create a vector2 struct here, but that would be implemented in the math.vectors module. So there's the create function, which can be called on creation, and this will have values x equals 0, y equals 0. But it might make sense to have casting be similar, like I don't know if that makes sense. I mean, it's always kind of bad to add more keywords, in my opinion. But then that would make it so that you don't have the weird parentheses just like before the variable. So it's like some kind of explicit conversion. Oh, but then obviously there has to be a return type, so it's a return type of vector2. So I want to do cast vector2 vector3. So that's casting from vector3 to vector2. Okay. What am I storing the position as? Vector 3, because it's a game object, that's right. So let's make this like 10. 256, and then 0. And for 1, 502, 256, 0. Okay. I also will make it like public variables from the window class or window module. You can just do like green height. Maybe just as a variable, not even a function. let's divide by 2. Okay, so this isn't a working Pong program in any way, but it is sort of the backbone of one, and it contains, it should contain 2 paddles, drawing, and they can move up and down, and they're limited by the screen height. Oh, and I should actually change this as well, so it shouldn't be 512, but rather screen height. Screen height. So these won't be defined until window create is run, but I think that should be fine. Also, everything by default in the language is initialized with a value. So if you do something like, is there a place? Yeah, okay. So if you have float rotation, for example, this is initialized. You don't have to do float rotation is equal to 0. These mean the same things. But there is probably a time where you would want it to not be initialized. Whether it's for performance or you're just wanting to allocate the memory or something like that. So I also need to think about how I want to handle that. I could maybe just say is equal to like is null. Or maybe void might make sense in this case. I think I'll use void. Oops. And that way, for example, sprite 2D, if you have some sort of create function that takes no string path to the image to load, then it doesn't actually have any images loaded. So that would save performance, potentially. I still think it's kind of weird maybe to have these as the effectively function names, but it does sort of make sense because you are in the background. I guess you are kind of calling a function like for casting. So I think I'll leave it like this for now. Yeah, so for the most part, I think this is okay. I think I can start maybe working on some kind of output, just, you know, to get some real code out, regardless of, you know, what it is. So we'll just make like C++ or something, and then it'll compile separately. Though it will be LLVM someday in the future. So we'll call it let's see. Okay, I have no idea. I'll just call it maker. Or output builder. And let's see. So I guess I can use project directory, and then let's create a function called build output, and just pass the AST node tree. Create a build directory, it doesn't exist. the directory that it creates is going to be project directory plus build, I believe. Yes. And let's see. Run the function. I'm not sure if this one will need to be recursive, but I guess I might as well have that functionality if needed. Oh wait, no, of course, it will need some kind of recursion because of its... Yeah, because it's traversing a tree. Although it could just be done with a loop. I might need to update the node tree, I guess. Because it may need extra variables to keep track of which nodes have actually been built already, but we'll see. I'm not really sure what the output should be. Might make sense for it to just be a vector of strings. Alright, so it might help to actually have some kind of output here. So let's go here. I don't need tests anymore. Oops. Split. Alright, so we're gonna just try to make like a super simple output currently with like a main function and maybe print. Currently, print is implemented. Well, it's not implemented. But I was trying to think of a good way to implement it, because I could just borrow printf or put s from the C standard library. And I probably want to borrow as much as possible from the C standard library, or, you know, like similar. Just because it's going to be really hard on me if I have to make everything on my own. So I was thinking I could include libraries like this, and define foreign functions like this. So I think I can try just doing that, because I mean that'll make conversion to C easier, or C++. Oh, and currently I'm getting a lot of warnings for undefined nodes. I can fix that because those are all looking at white space. So build output was not declared. Oh, it's right. Oh, I forgot to include it in my CMake file. I know it's very disorganized, but it works. I also didn't include vectors. Or a string. Awesome. So now we should see that we don't get all those warnings anymore. We're still getting a lot of warnings. For mostly new lines, it seems. Oh, that's right. I also need to add a case for new lines because those are stored as something different than nothing. This main file is getting very large. Okay, I'm not sure what those are for, because they don't have a symbol following them. Well, it's fine. Start working on the output again. Let's have a switch case, I guess, for the type. Or, let's make this build function be a recursive one, and then this one, that way this one wouldn't have to be. Because I'm going to be adding a lot of like boilerplate code. Yeah, and then I can just run build on each of these. I'm not entirely sure how I'll do code generation. I might have to add a individual like vector of strings for each node on its own and then combine them later on. I don't know, we'll see. So I think I'll just start off with like compiler define. That way I can get like the main function defined and start actually getting some real code in here. So there should now be a directory since I've already run the compiler at example slash start slash build. and I'll just call it main.asa.c++, I guess. Right, so compiler define. I should probably have more than one type of compiler define now that I think about it, because I have macros, and I have structs, and I have functions, not to mention what I just implemented in Pong, which is like a struct, which is derived from another struct, as well as casting and creating. So I think I'll do that first. Oh, and modules. Right, so down here, I think this is only for functions. I guess I can have it follow the same sort of form factor. Let's see. Might be a little more difficult to differentiate at the AST build stage. So I might just leave it as only functions currently. I think that's it. Oh, a test failed. Oh, that's right, I have to update the test. Tab new. Alright, and then where these contain compiler define, the macro, that's fine. This is a function. This is the old syntax, so I should probably change that, but I'll leave it for now. think the music stopped. Let me just fix that real quick. I'm also going to just do a quick, like, 2 or 3 minute break. So I'll be right back. Right, I'm back. All right, so let's change this to compiler defined function. So if it's a compiler defined function, then the first argument is the identifier. If there's a type, then it's return, and if there's not, then it's void, or it's, I don't know what I just said. If the return type is defined, then we have to set that. And then there's argument, Mains aren't defined the same way in ASA as they are in C++, but I don't think I'm going to be doing anything with command line arguments, so I might just want to leave that the same. Or I could just do a special case. I think I'll just do a special case for now. So let me just define some tools to make this a little less repetitive and easier. First dot token dot first. Wow, that's quite a mouthful. Wait, that's the same. That's what changes. Okay. All right, so if the first token is main, and I think what I'll do is just sort of like create it manually. See if this even compiles. Oh, hold on. I did that wrong. Wait, why did it test fail? I thought I changed that to compiler defined function. Oh wait, it failed to compile in the first place. Oh, I see. Awesome. And then also just for testing, I'm going to already have it print out So let's see. Output string. Or maybe I can just have something in the file manager. Save vectored file. Oh, I suppose I can do that down there. And I don't need the extra variable as well. Okay. The file name would have to be... Oh wait, hold on, I thought I already saved the file name somewhere. Or no, that was the creation of the directory. Project directory plus build. Yeah. Plus the name. Let's see. So I need to get the file name. Probably want to use file system again. Let's see, what's this? Great. Plus base file name, and then I also want to add the C++ extension. And the vector that will be saved to the file will be the output code vector. See if that compiles. I have to include that. Oh, I did include it, so it must be extern. Yes. Awesome, that works. Function definition not found. Oh, that's right, because I commented all that out. We'll handle that in a sec. We'll just get some more functionality first, and then we can do that. Function definition not found. Really? Oh, that's right, the dependency checker. I didn't update that code for functions. Yep, it needs to be compiler defined function. Or compiler defined, because it can't tell if it's a macro or a function definition, so it should be able to search for both. Okay, and that works. And we have an output file. Obviously it's bare, it's just the boilerplate and then the beginning of a main function and nothing else. But we'll add some more functionality now. Okay. Also, I can just be using add now. Forgot I made that. Alright, so the main function is a special case, but we'll have an else so that we can handle it like handle any other functions. That would be let's see, if it has a return type, then that's second, I think. Yeah, if second is equal to type. Then add second dot child nodes 0 dot token dot first. Otherwise void. Currently, when I do add, it makes it multi-line. Each one of these is a line. I don't think that will really matter to C++. The compiler won't care. Okay, so that's actually really good. We have yeah, all the different functions are being added in. It doesn't look good currently. Also, we don't have any arguments either, so let's do that as well. Alright, so arguments are defined basically the exact same as they are in C++, at least currently. Let's make some kind of offset, I guess. Because that way, if second.noType is a type, that means we have to increment the offset by 1. And then now when I use second, it's actually referring to the third thing, which if there is a node type, or if there is a type, that would be the argument, and if there's not, then it would still be the argument. I can just do for const auto a in second child nodes. And then those will all be expression terms. Although I'm not really sure why this one has an expression term with something and then an expression term with nothing. It's kind of weird. Oh, maybe it's the ... dots that I have. The ellipses. Yeah, I don't think I actually added a handle method for that, a way to handle those, so. Redeclaration? Okay, let's change this to something else then. Oh, oops. Am I misunderstanding something? Ah, okay. I had to be out there. Oh, I'm already at 1. Okay, let's see what that outputs. Alright, so now we have all the functions almost completely made. Now I just need the names. Oh, that should be before the arguments now. So now that will be first token. Alright, thanks for watching the stream. Good night. This is probably going to be a shorter stream than it was, what, 2 days ago? That one was like 7 hours, I think. That was pretty long. So this one's going to be shorter. I'll probably end at 3 hours. We're at 2.5 now. Okay, so there's this function here that doesn't seem to be building correctly, and I'm not sure why. It doesn't seem to have a name. And it's defined after main. Isn't multiply defined after main? Yes, it is. Okay. I see the issue. It does have a type, but I am still trying to access the actual first token. Probably just like have that up here. And I can use a stack to just temporarily hold this. Typos. And I'm going to also add push and pop here. And so what pop will do is it'll actually do add temp stack dot pop, and then do temp stack dot pop. Oh, and it doesn't need variable like that. Okay. There we go. Now we have all the names and everything. All right, now let's work on arguments. You know, this might actually be kind of a waste of time for me to do. That is compiling to C++. I don't know though. I guess I can still like do some basic compilation though. Alright, so we're iterating through the child nodes and looking at arguments. And each argument is an expression term. Although I'm not sure why it has extra. So I think multiply, that's like a normal function. I think even that one does. Oh, never mind, it doesn't. Okay. So if the expression has children, then that means it's an actual argument. And now that I think about it, I'm going to actually need to have a separate vector for adding prototypes at the end. because C++ it kind of matters the order in which you define something in your file, which is super annoying. But in ASA, that doesn't actually matter. So I'll have to make sure that all the prototypes for the functions are defined at the top. Right. I'm not sure if that extra comma will throw an error. Should probably try actually compiling the code. So let's see. Out of that. And then I want to run G++. Oh, what? Hold on. Why did this file change? Okay, it's kind of changing as I'm looking at it. Maybe it's my automatic compiler. So then this will be example slash start slash out. Oh, slash build, I mean. Thought it was in the output folder. Slash main.asa.c++. Dash O. Example slash start slash build slash out or a.out. Okay, so we have C++ code compiling. Error expected identifier before write paren token. On 21. 21? Okay, I don't really know what line that's referring to, but it might be multiply here. I'm just trying to remove the comma. Oh wait, yeah, that it overwrites it. I think I actually need to change this. And if I is less than the child node's dot size minus 2, add a comma. No, it must be minus 1. Okay, that's better. Maybe not. Do I have to do an and? Greater than 1? No. Oh, that's right. These have the dot dot dots. Ellipses. So in that case, let's see what makes those different. I think what I should do is actually just define those. Because I have dot dot defined, but I can also just define dot dot dot. Argument list. Where did I put that? Under range. Error expected type file by identifier. Is that an error for me or an error for... yeah, that's an error from me. Okay, so print token error. Actually, I can just do this. And the token is arguments a token, I believe. Invalid initialization of reference of type token pair. Is that the wrong order? I think it might be. There we go. Expected type file by different. Okay, it doesn't have a token associated with it, I guess. I guess I can just do node. Token associated with that. Well, now it's pointing to the wrong spot. Music's gone. Hold on, let me just fix that real quick. It's pointing to the wrong spot. You should be new node. No, it's still not working. Oh, maybe it's because it needs to be... Hold on, this music is really loud. Alright, so... the first leaf node, I think. There we go. Expected type followed by identifier. It might make sense, actually, for me to force you to specify the type. I don't know if that would just be needlessly limiting, though. I guess I can do that temporarily. Actually, no. That wouldn't make sense for printf because you can have any number of arguments of any type, and that just makes sense. So I just need to add an extra case. What was that new type I just added? Argument list. And I think that's good. Node type. All right, that works. Now let's just compile that as well, and obviously there's still errors. Oh, I'm including the dots? Why is it added twice to the argument list? It should only be added once, so that's kind of weird. Oh, is it even added as a leaf node? It may not be. Add node is leaf. Oh, no, it already is. There we go. And now I just need to add in the check inside of the builder here. Oh wait, never mind. It should already be automatic, I think. It's adding 2 again for some reason. Okay, that seems to work, I guess. No, it's still including multiple. Oh, the reason that's happening, I know why that is. That should be checking if it's exactly equal to 2. Also, if it's exactly equal to 1, then just add the first one. There we go. I'm gonna need more boilerplate code. Because strings and lists, which in C++ are called vectors, are default in the language. Oh, did it actually work? I have to actually run the program as well. I think it's working. I mean, in a basic sense. I mean, it's not exactly a functional program. It doesn't do anything. But yeah, it's doing something. And that is compiling. Also, obviously, it's just transpiling to C++, which is kind of lame. But that's only temporary. Let's also just add a vector for prototypes. Which you can just add. Just make this separate, so it's like add boilerplate. And then there's add prototypes, and then there's just add. And I can just do this for each of those vectors. that's right, I need to change this. And I can build the prototype incrementally. Oh, we've gone past 3 hours. Okay. Let's see. So let's just build this, see what we have so far. Obviously not completely executing the program, but it's like a start. Alright, so that's the output, and it also creates this prototype for main, but I obviously need to do that for all the other functions as well. And it executes without an error right here. There's no output, so you can't actually tell, but it is running it. But basically, that's probably all for today. Thanks for watching, and I'll see if I can stream sometime again. Let's see, today is Thursday. Sometime again this week. So thanks for watching, and I'll see you next time.